Okay. So good afternoon, everybody. Welcome to another NetPlace seminar. Today's speaker is Lucio Cava. He is from University of Calabria in the south of Italy. And he's going to talk about researching next-gen social media ecosystem. And the discussion part is going to be about scientific research in the age of big players. So Lucio, whenever you're ready.
Thanks for the introduction. So, hi everyone, I'm Lucio Cava, assistant professor from the University of Calabria, and today I'm going to talk to you about researching next generation social media ecosystems. Okay, so everything starts with the idea of social networks. Basically, social networks were designed with one shared goal, which is the one of shrinking times and distances in interpersonal relationships over the internet. And all we know that they were actually successful in this because they easily became parallel worlds to the physical one. And what we know is that traditional centralized online social network like Twitter, which is now X, Instagram or Facebook, gained a lot of popularity. But we should account for some issues that characterize these social media platforms. And the first one is the lack of owner scalability. So typically these platforms are owned and controlled by single entities like a person or company, and this might lead to the emergence of side effects, such as privacy and policy concerns, information bubbles, or unexpected policy changes, like the one we witnessed with Twitter. So basically, we have to deal with the fact that not all that glitter is gold. And these are some headlines that shed light on some potential issues deriving from these centralized social media platforms that also impact the way we do research on these platforms. Okay, so as a reaction to these issues that characterize centralized social media platforms, people started thinking about a paradigm shift. And this is the one of decentralized online social networks. So basically, the idea is to develop some social platforms that bring back the user at the center of the stage. So we have a user-centric vision. And the idea is that we want to foster spontaneous and unbiased interactions. And we want to get rid of all the advertisements that every day flood our timelines. And the other idea is to foster this kind of decentralized growth. So basically, we want the formation of independent yet cooperating servers. And this is something due to the need to escape from individual owners. Okay, so basically, how is decentralization achieved? First of all, we need open source software that allows anyone to create a new server. In this context, servers are dubbed instances. And the idea is to favor the emergence of communities that are guided by spontaneous interests or topically bounded. Let's say you can imagine lots of subreddits. On the other side, of course, if we scatter these platforms across the web, we need a way to link them. So basically, we have some specific communication protocols that enable the seamless communication between users that are registered on different instances, but also on different services, so different platforms that pertain, basically, that embrace the same protocol. So basically, you can imagine people on Twitter talking with people on Facebook and talking also with people on YouTube. Okay, this is something that is achieved thanks to protocols like the ActivityPub1, which is the one that characterizes most of decentralized platforms. Okay, so talking about decentralized social network, the most relevant, the most well-known platform is Mastodon. Mastodon can be seen as a decentralized alternative to Twitter. And it also brings some interesting concepts from Reddit, like communities and content moderation. Mastodon uses this kind of ActivityPub protocol, which is a protocol that allows for the client-to-server communication, but also server-to-server communication. And each server is subscribed to the other servers to ensure this kind of seamless communication among the services. Okay, so Mastodon introduces a new kind of fellowship mechanism. We can call it extended fellowship mechanism because basically you can follow people that are on the same server of you, but also people that are on different server. And one of the major example of this kind of paradigm shift is that, for instance, Threads by Meta embraces the same protocol of Mastodon, and basically from Mastodon you can comment on content within Threads and vice versa. And the other important point on Mastodon and generally on decentralized and social media platforms is the possibility to have fine-grained instance control. So basically, since there are interactions among different servers, and some of these servers, of course, can host some harmful content, you can also decide to filter out and block or prevent the interactions with this kind of harmful servers. Okay, let's zoom out a bit because actually Mastodon is just one little part of a biggest project, which is called the Fediverse. Basically, all the services that you see depicted on this slide are services that mostly embrace the same protocol of Mastodon, the ActivityPub1. And so this means that basically by just having one account on one of these services, you can interact with all the other services. For instance, Lemmy, which is the decentralized alternative to Reddit. Okay, so the Fediverse is something very active and it's thriving. Basically, there are more than 149 different projects in the Fediverse. It's gaining momentum, so it's collecting more and more users and different servers. But of course, the numbers that I'm reporting in these slides are an underestimate of the actual number of people and services in the Fediverse because of decentralization. So it's very difficult to track the evolution of these platforms. Okay, so actually we started focusing on Mastodon some years ago, okay? And we started looking at the interactions that happen within Mastodon. And in particular, we started by collecting data. The very interesting point is that Mastodon has some free-to-use and open APIs, so you don't need to pay for accessing data, okay? So we developed a very polite data crawling process. Basically, we discard any textual component and we only focus on anonymized networks. And we crawled more than 28 million raw links within Mastodon. So we started from a seed set of instances and users, and we expanded the networks. Basically, we came up with more than 1 million users and 18 million links. And from these users and links, we extracted 16,000 instances. So these users pertained to 16,000 servers scattered across the web. Okay, as I told you before, Mastodon is one of the servers on the services, let's say, within the Fediverse. So basically, these 16,000 servers are not only Mastodon, but also other servers and services. And so what we did is we conceived different networks, and in particular, different views over this giant interaction network of servers, considering the expanded instances network, which is the one that accounts for servers that are within Mastodon, but also from other services that link with Mastodon, the instances server, which is the one of only Mastodon instances, and the online instances, which is the one that actually considers only the instances that were online at the time of carrying out these studies. Okay, so basically the interesting point here is that the rest, let's say, differently from what we typically did on Twitter, for instance, where we have only users as a perspective, here we can take another perspective, which is the one of instances, because we know that there are users that are within different instances. These users can interact across the instances, and so basically they determine interactions across the servers. So this is the first, let's say, perspective we took, and in particular, we focused on the so-called instance level. So in the network modeling that we used, each node is an instance, and there is an edge between two instances if there are basically users from these instances communicating with each other, so following with each other, of course, in a directed way. So it's the fellowship relation. And this is an overview of the network that we obtained upon this data. Basically, the white nodes are the Mastodon nodes. The blue nodes are the servers that are non-Mastodon. So you can also see that basically servers from other platforms are linking with Mastodon. And the interesting point, of course, is that this giant node at the center of the picture is Mastodon.social, which is basically the first instance, the first server that was developed with the Mastodon project. Okay, so basically we started characterizing the instances network, and we started with this idea of triadic closure, because as I told you, there are lots of independent servers, but they are supposed to cooperate, because basically if the servers were remained isolated, let's say the ecosystem will collapse. And so we started looking at the transitivity and the local clustering. The transitivity is, of course, low, given the sparsity of the network, but interestingly, the local clustering is very high. And coupled with the high fraction of reciprocal edges that we found, we spotted basically this kind of federative structure. So the instances are all independent. So instances were created by different people, but they tend to cluster together. So they tend to link with each other, allowing for the sustainability of the entire decentralized ecosystem. The second interesting point is the one of degree assortativity. So typically we're used to expect positive degree correlation. So basically what we expect is that relevant people will get in touch with relevant people. Okay. What we spotted concerning the instances network is that we have negative values of degree correlation. So the so-called degree disassortativity. So this means that basically it's not a popularity-based attachment that drives the relations between the servers, but topically induced linkage. And this is also something, again, interesting that supports this idea of coherent ecosystem despite the independence. The third point we investigated is the one of community detection. Basically, we used the Louvain and InfoMap methods, and we spotted evidence of a modular structure within the instances network. So instances tend, again, despite being independent, to cluster together. And basically, the interesting point is also that despite being in different modules, the conductance, so the flow of, let's say, information between these instances is very high. So we also investigated the reason for community formation, and we discovered topics, languages, and temporal processes like the creation time as the main influence factor for community formation. So basically, communities contain instances that deal with the same topic, or instances that deal with the same language, and this is, of course, expected. But interestingly, communities contain instances that were developed during the same time. So what we spotted is, for instance, the servers that were created at the beginning of the Mastodon project form a separate community. Okay, another interesting point we took is the one of color decomposition. So basically the idea is, okay, let's assign each node with an integer that captures how well the node is connected with respect to its neighbors. And basically the higher, let's say, your interconnectivity, the inner the core you pertain. And the lower your connectivity, and you, of course, pertain to the periphery of this network. And what we discovered, this is very interesting, as depicted by the directed arrows in the plot, is that there are very central, very relevant instances, which are in the innermost cores of the network, that tend to link toward the instances that are in the periphery of the network. And again, this is something counterintuitive, because basically we would expect that central instances would link with central ones. Okay, so again, this is something that supports the idea that here interactions are no longer driven by mere popularity, but by topical interests or other kind of interests. Okay, so then we took another perspective, which is the one of users, okay, the most common perspective. Here, each node is a user, and each edge between users represents a followership relation between those users. Basically, what we did is we carried out a lot of structural investigation on the network formation involving users. And an interesting point is that the results that we reported in this study referred to a very high coverage of the Mastodon user base at the time of writing that work, because basically we were investigating about the 70% of the entire user base of Mastodon. Okay, basically these results confirm what we spotted with the structural analysis of the network, of the instances network. Okay, but what we discovered is that basically, if we consider the top 5 most relevant instances we spotted in the first study, we can use them as a proxy for studying the entire Mastodon, let's say, network. And this is something that, of course, facilitates the investigation of the user network. So basically, we focused on these 5 instances that were the most relevant at the time of writing this work, and also on the merged network. So basically, the network stemming from the union of these these individual networks. So basically, all the interaction within and across these 5 instances. And this is, of course, a visualization of the network we obtained. Here, each color is a different distance. Okay, so at this point, the idea was, okay, decentralization should have an impact on interactions and on user behavior. And we wanted to investigate what is this kind of impact. So basically, we started by looking at strategic user roles within the Federals. And the first user role we focused on is the one of bridges, because basically we know that this kind of decentralized network is scattered across the web, so we would expect that people will interconnect through their links the different servers. And in particular, we use this kind of directed topological overlap. So basically, the idea is that we want to compute the fraction of shared neighbors a pair of connected vertices has, such that the lower overlap, the higher the strength as a bridge. And as you can see on the table, what we discovered is that most of the users within these instances and also within the major networks act as bridges. So they are in charge of linking diverse regions of the Mastodon federates, of the Mastodon network. The second, let's say, user role we focused on is the one of lurkers. Basically, this responds to the participation inequality phenomena. So just a small part of us is very active on social platforms, and typically most of the people are silent rather than inactive. So these people tend to gather, let's say, information capital, social capital, and they have a lot of potential in achieving information. So basically, we want to detect this kind of users. So we resorted to an eigenvector centrality-based node ranking problem and algorithm for basically identifying this kind of users. And the idea is that the strength of a lurking status depends on the overconsumption, on the authoritativeness of the information lurkers receive, and the non-authoritativeness of the information lurkers produce. And what we discovered is that basically, if we narrow, let's say, the focus on very strong thresholds, the amount of lurkers is very small. But if we, let's say, admit some larger thresholds, the fraction of lurkers spotted within the Mastodon user network tend to increase. And basically, what we did next is as follows. On the right, you can see the flow of information between the 5 most relevant instances we detected. And you can see that actually there is a huge flow, especially from Mastodon.social, which is the most important, the foremost platform, let's say, server in the Mastodon project. So basically we said, okay, let's see what is the fraction of edges that goes towards lurkers or that comes from lurkers. So basically, are lurkers absorbing information or diffusing or producing, let's say, information that is spread across the network. And what we discovered is that, of course, for the latter case, for the second case, lurkers do not tend to produce information, okay, by definition, but lurkers tend to absorb information. But the interesting point is that lurkers tend to absorb information not only in the instance they're registered on, but also across instances. So they tend to absorb also links coming from other instances, okay? Okay, at this point, we said we located 2, let's say, strategic user roles within the federates. Let's check if we can spot users that act both as lurkers and bridges, or in an alternate way as lurkers and bridges. So for the first case, we want to look at users that are at the same time lurkers and bridges within the same instance. So basically, they tend to absorb information as lurkers and let information flow through the links as, let's say, bridges. Okay, as you can see on the top table, that's not the case for most of the instances, but Octodon Social. Octodon Social is a very small instance in the project, in the Mastodon project, despite being relevant. And here we spotted a non-negligible fraction of users that act as both lurkers and bridges. Something more interesting emerges from the second table, the bottom table. Here we want to spot users that are locally identified as lurkers and globally identified as bridges. What means global bridges? So basically, local lurkers, this means that they absorb information produced locally in the instance they're registered on, and global bridges means that they tend to let information flow across instances. So, for instance, if we consider, for example, if we consider users on Mastodon.social, they are local lurkers if they absorb information, content, let's say, produced within Mastodon.social, and global bridges if they let this information flow toward the remaining instances thanks to the fellowship relations they receive, basically. And what we spotted is that the fraction of these users is not negligible, and we dubbed these users information flow facilitators. The opposite doesn't hold. So basically, the fraction of users that are local, let's say, bridges and global lurkers is a bit more difficult to achieve. Okay, the third, let's say, pillar we investigated is the one of migrations. So basically, all of you know that at a certain time, Elon Musk decided to buy Twitter. Okay, and you all know also that he started taking very strange decisions. And basically, these kind of decisions were reflected in the number of registration on Mastodon, as you can see in this kind of plot. So basically, when Musk completed the purchase of Twitter, people started registering on Mastodon because it's the closest platform in terms of user experience. When Musk started laying off people increases the number of registration on Mastodon, and so on and so forth. So basically, people established this kind of Twitter migration. Okay, this was a movement, let's say a social movement. And the idea is, okay, let's check if this kind of Twitter migration is sort of driven by social influence. And what we did, basically, we started collecting data from Twitter when it was possible. And basically, we started collecting data of people claiming their idea of migrating to Mastodon, using the Twitter migration hashtag, or advertising their Mastodon handle to ask people, okay, follow me on Mastodon too. And basically what we did, we collected 75,000 Mastodon handles. And interestingly, we had a 98% matching rate. So when we were able to check on both platforms the matching of the handles, so basically users using the same handle on both platforms, the matching rate was very high. And so we constructed, on one side, the Twitter migrated network, so the network of people on Twitter that migrated to Mastodon, and on the other side, of course, the Mastodon follower network, so the network they reconstructed on Mastodon. And basically, the interesting point is that what we spotted is that up to the 41% of the links we observed on Twitter were replicated on Mastodon at the time of writing this work. And this work was made during the migration. So basically, people actually recreated most of the social ties, even on the new platform, okay? And basically, also the let's say, the shape of the social ties was very similar, since the, let's say, the Spearman value between the ranking of the local clustering coefficient was very high, the correlation. Okay, so at this point we said, okay, let's suppose the social influence is actually a sort of infectious progress. So what we did basically is we used the Mastodon registration time, because it's an information we had, as a proxy for the signaling, okay? And basically we fitted some epidemiological models to approximate, let's say, this data and simulate the tendency to migrate as an infectious progress. What we discovered is that basically the infectiousness, so the tendency to migrate, is very high. And at this point, we started looking at the fact that this kind of hypothesis could be, let's say, community-driven. So different types of users, different communities, tended to migrate with different, let's say, strength. Okay. And so basically what we did, we started looking at communities on the Twitter migration network. And basically we discovered high variability in the value of infectiousness from these users. And this again suggests, let's say, supports our idea of community-dependent social influence. So basically we started investigating which can be, let's say, the role of network topology, reiterated commitment, and language use in such a variability of infectiousness, so of tendency to migrate. And we started with network topology. So basically we correlated the R0, so the infectiousness, the tendency to migrate, with some network aspects. And what we discovered is that R0 is weakly correlated with community sites, but it's correlated with, let's say, sparsity. So basically the sparsity of the social connections fosters the prominence of Twitter migration tweets. So if you are in a very sparse network, it's easier that you get in touch with a Twitter migration tweet, and also the proportion of migrated friends. So if you are a more sparse network, it's easier that most of your friends tend to migrate. This is very challenging to achieve in a very dense network. Okay, also we focused on reiterated commitment. So basically we crawled tweets posted during the first month of this kind of movement, and we used the fraction of Mastodon-related tweets as a proxy for commitment. And what we discovered is that the more people talked about migrating, the more they were, let's say, propense to migrate. And again, this is something that leads to suggest us that people were committed to migrate. Okay, the third point is the one of language use. So basically, we use the social dimension classifier to identify which are the social dimensions that were in charge of increasing the tendency to migrate to Mastodon. And basically, we discovered that R0, so this kind of tendency, correlates with knowledge and identity. So basically, people which were more inclined to, let's say, migrate to Mastodon were people looking at information exchange. So the idea, okay, if I move on Mastodon, I can also have a broad information exchange, and also the sense of belonging to a shared group. Okay, so basically, if all of my friends or my community migrates to Mastodon, I'll also do this. Okay, so at this point, we came up with a lot of, let's say, hints at correlations, and we decided to fit some prediction models to see if we can basically predict the tendency to migrate based on the cues we spotted so far. And basically, what we spotted is that if we combine topological, social, and activity features, we can explain up to almost the 60% of the observed variance in migration. So basically, we also, let's say, can sort of predict the tendency of users to migrate. Okay, so this is just a small part of the works we did on Mastodon. This is an overview of what we did and what we are doing on Mastodon. So, of course, if you're interested, you can look at this paper. Okay, that's all for the, let's say, scientific part. Thanks for your attention, and feel free to ask me any questions.
Thank you, Lucio. So if anybody has question, can just unmute itself and ask, or chat in the chat. I can start maybe. So from the first part, that is the network of the instances, can the result about the core periphery relation be linked to the anti-correlation in degree, as like how do you call it, the
Degree
disassortativity? Thanks.
Yes, of course, the link, because this means that are very relevant. When we decompose the network, okay, into nested cores, we actually consider the degree of the
Okay.
of the
Yeah.
nodes of the instances. So actually, yes, it's a different perspective on the same phenomenon.
Yeah. And for the second part, maybe I lost the explanation, but is the migration process one in which a user stop being a user in Twitter and start being a user in Mastodon, or it keep both profile?
Okay, so thanks for your question. Actually, when we did this work, the migration, let's say, was not complete at all. So we didn't consider the possibility to turn off, let's say, the Twitter profile. Okay. What we discovered is that people, so we also looked at these users some months later, the migration, the big migration, okay? And what we discovered is that not all the users remained on Mastodon. Okay, some of them actually, let's say, deactivated their profiles, or they remained inactive. But the users that after the migration, so the migrants we spotted, remained active on Mastodon, were, let's say, super users of Mastodon. So we're particularly active on Mastodon. So this is something very interesting we spotted. Yeah.
And also the last question is like, damn, I forgot. Yeah. How do you do the matching between the user. Like
Yeah.
it's like which information do you have to do the matching?
Okay, basically what we had is, okay, users on Twitter started advertising their handles. Okay, typically also in the profile description. Okay,
Right.
that's my short
Okay.
information. My Mastodon account is. Okay,
Okay. Okay.
and some of the people, okay, on Mastodon started saying in the let's say user information, I was user X on Twitter.
Right.
So basically, in this case, we had a bidirectional, let's say, linkage, and in the 98% of the cases, we matched the users because also at the beginning, users um, used some tools to simultaneously post the same content on the two platforms.
All right.
So basically, we were able to spot both, let's say, directions
Yeah.
of.
Okay.
Yeah,
Thanks.
thank you.
Some other question? Go. Oh, yes.
Yeah, my question would be like, did you see any differences between the time and the time of the migration between the groups? Because like I think like in the scientific groups, like it started earlier, like talking about Macedon and we should move there. It's like that, but like maybe like in some like gaming communities or like some fun activities, like it changed later, and also like maybe in like some financial groups, I don't think like they try to leave at least. Like, did you see these differences in terms of the time and like the behavior?
Yeah, actually, we didn't look into times because the funny fact is that we carried out this study just we started collecting data between January and February, and then Musk, let's say, stopped the free APIs. So it was such a rush collecting data, and also the time frame we basically this kind of big Twitter migration happened is very narrowed. So basically, it's 1 or 2 months. So we cannot basically spot, let's say, tangible differences in time. But of course, we know that typically academics were among the first to, let's say, explore the new ecosystem.
Okay.
Yeah.
Okay, thank you.
Any more question? Okay. I think we can switch to the second part.
Okay. Okay, so for the, let's say, second part for the discussion, I want to discuss a bit scientific research in the age of the big players. Okay, this is something I think very timely and very that concerns all of us. So basically, that's the current scientific landscape. Scientific research we know is advancing very rapidly recent years, and we achieved unprecedented evolution in different fields. So AI, network science, and computational social science, for instance. And most of the breakthroughs typically come from major players. So Google did this, OpenAI did this, Meta did this, and so on and so forth. And so this seems that computational resources like massive GPU clusters, paid APIs, and the access to proprietary datasets seems to be the major bottleneck for the rest of us, the rest of the world, let's say. And actually, this means that we should consider this kind of elephant in the room. Okay, these are some headlines. Of course, they concern AI because it's maybe the sector where, let's say, industry is most dominating now. But I think it's something that's also basically touches computational social science, network science, and other domains. And the problem is that most of us, let's say, we'll ask this question. So, can early career researchers still make meaningful contributions in the age of big player? Okay, and this question is not random. It's driven by these perceived challenges. So basically, we are dealing with typically with limited resources. So we have no access to expensive GPUs or cloud services, and most of the large datasets are typically inaccessible. So you can, for instance, think about the study Meta conducted with people on the elections, the US elections. Okay, this data is not public. So basically, you have to collaborate with a company to access this data. And that's not the only case we consider. And also, the problem is that what we perceive is that there is an industry dominance. So basically, leading companies set the research agendas. So now we have to work on graph neural network, everyone will work on graph neural network. Now the trend is working on LLMs, everyone will work on LLMs. And also this is something that relates to the barriers to entry. So basically it feels like only well-funded institution can keep up the pace with this kind of science. And also visibility. So typically corporate research overshadows independent work. Okay, look, OpenAI released this, Meta did this. Okay, and even if, let's say, young researchers achieve some very impactful research, they typically tend to remain overshadowed. And also the impact on publication. Let's say something we perceive is that to have meaningful papers, okay, we have to achieve corporate backing. And okay, actually, I want to challenge these perceived challenges because I don't think this perception is entirely true. Okay, but before doing this, we have to deal with this kind of elephant in the room because these kind of challenges I mentioned sort of shifted the way we are approaching research as young researchers, impacting also the view of the potential our contributions might have on the literature. First of all, relating also to Arianna's talk, is the imposter syndrome. So basically, when we do something, typically we ask, okay, how can I compete with the achievements made by big players? Okay. And also, it's this sort of resource anxiety. So basically, we have this feeling that without computing power, we cannot do research. Okay. Actually, I want to challenge this perspective. To me, it's not entirely true, because basically we have to bear in mind the actual nature of scientific progress. The idea is that, of course, science is a mosaic of, let's say, contributions, a mosaic of different aspects. It's not about the size of the contribution, but about how this contribution adds to our collective understanding. So it's not about training giant models. It's about the impact that our contribution can have on the understanding of the society and, let's say, the complex phenomena we deal with every day. It's not about the answers, but also about the questions. So basically, I also work on LLMs, and typically we wait for big release by these companies. But of course, we sometimes, okay, we're unable to, let's say, give answers, I mean, concrete answers, because of course we need some computing powers. But we can, let's say, post questions. For instance, we can check whether, in the case of LLMs, there are some emerging phenomena, some emerging biases. And this is the case, for instance, of some big players that used, like Anthropic with Claude, some, let's say, young researchers studies to mitigate the emergence of biases in their models. So we can still make some meaningful contributions. And let's say, most importantly, is about the way we look at numbers. So it's not about computing. It's about curiosity. It's about our individual perspective to make meaningful, let's say, contributions. It's not just about computing. So basically, I want to, let's say, start the discussion with the slide because actually your role and our role in the scientific progress is key. Because basically, scientific progress is driven by diverse minds. It's not just big players. And computational power, of course, is a very useful tool. Okay, everyone maybe is using some heavily computing tools. Okay, but creativity and collaboration are the actual drivers of breakthroughs. And of course, your perspective, our perspective, and research matter regardless of the funding and the resources we have. So I want to, let's say, conclude with this provocation because actually I think that the next breakthrough in science might not come from thousands of GPUs running for hours, but from you or us asking questions nobody else thought about. Okay, so thanks for the attention and let's discuss about this.
Thank you, Lucio. Somebody has some comments.
I mean, there was like a post by Aaron Closet like a few days ago. He said like basically like addressing this point, like that the science is also not about like these curiosity and the other things. It's about like the people. It's like how they like try to contribute in a scientific way, and they try to like address it. So like it's about like how we collaborate. And if we don't exist, this science also like is not in the way that it is right now. So I really agree in the way that you're talking about, but it's also something else that I would like to say. It's like not every work is like a breakthrough, but it's like a step to build on top of that. Like I think it's really calming to think about it. It's like if your paper is like not getting thousands of citations, but somebody is building on top of it, and like another person is building on top of that. So it means that there was something inside that it was like building on top of it. So it helped to advance. Maybe it didn't help you in order to do all these things, but it helped others to do that. And that's also what I think it's an impactful way of thinking about like the science and these kind of things.
Yeah, I totally agree with you. And indeed, I refer to the mosaic as a, let's
Yeah.
say, metaphor. Yeah, yeah. When I talk about breakthrough, it's not about, let's say, the raw number of citations. It's about the impact it has on the let's say, research community, the scientific community. So I totally agree with your perspective.
I mean, I can also say like it feels so like strange nowadays that we are waiting that somebody does something in a company and we are waiting to research about it. It's like somehow like we are attributing all money, all energy, our working loads in order to study a product of a company. And it is some sort of like scientific labor that if you think about it, maybe it's not all the time about the society, maybe it's about the company itself. Like in the way that you are like convinced that it is a research that you should do. It's also like an epidemic between the researchers that everybody should research about it. So I think these are the points that I feel nowadays that okay, like if I don't do research about AI, if I don't research about these kind of things, am I feeling behind? Is it like the way like people are still using like the cable telephones and like not the normal telephones? So like, is it like this or is it something good that I have to like stick to it? Maybe it's like about the blackboard, it's next to me and not like the, we don't know. So what's your perspective on this?
Yeah, it's sort of discouraging because basically they set the agenda.
Yeah.
Yeah.
Yeah. And I totally agree with everything you said, and about what was saying, yes, about this weird thing that we basically do our work for free for company. Made me think about like some days ago where I was trying to fill the form for OpenAI free credits for research. So I was like starting like with the idea that I have a project where AI can help me, not where I can help AI. Okay. But the question they ask for they to like grant you these free credits that I mean is not like credits that I need to like gain something economically, but like for proper research. So I
Yes.
expected that like I can like give you like a project that where I use AI. But instead, from what I understand from the questions, basically they expect you to like improve, I don't know, several aspects, but like within to improve the model itself. And it felt weird. And yeah, it made me think about that.
Yeah, I mean, it would be nice to see like what they are asking for. Like, I mean, when you say like, okay, like this is like costing so much, it is like costing like time and GPUs and everything. These like people say like use open source softwares and these kind of things, but it is basically the same thing. The hype is the same thing. Like it's like using Mastodon or like Twitter. It's all there about it. So yeah, I think understanding society is like a double sword. Sometimes we are helping to understand it. Sometimes we are pushed to understand something. So
Totally agree. Yeah.
I can have a provocative question, but it's actually an honest question that is like, company like Google have research unit.
Yes.
Okay. So some kind of creativity and collaboration, they also have it. It's true. So what would be the thing that differ from academia and what we young researchers are doing?
Maybe, I mean, it's very provocative, but it's the right question, because basically it's the aim. Because we do research, let's say, for understanding how things work. Okay. Of course, if you work for a company, the research you do is to improve products, basically. So that's
Yeah.
the difference.
Yeah, I mean, the question was going in that direction because I never worked for Google, and I don't know, and I don't know which kind of question do they answer to, or actually, I don't know how constrained they are in making question to the research, because we have silent constraint of the fact that maybe there is a topic that is more famous at the time, so maybe we can publish more if we work on that topic. But if you don't want to have that constraint, you can choose not to have it. So it's kind of self-imposed constraint, let's say. So. But maybe a research unit at Google has a fixed constraint that you cannot avoid if you want to work there.
Yeah, you should ask someone working for this company
Yeah.
to gain a different perspective, let's say. Yeah.
There are some more comments. Someone want to add the last.
I was like really looking at the bibliometric analysis of like NORIP's papers at some point, like for fun to see like how is it, because everything is free there, the database of the papers, like the reviews, everything, like who contributed, like what is the funding and everything. And this said something like very strange, like every year, like one of the at least like most of the best papers, most cited ones, like after some point, they are coming from like the good companies or high prestige universities. So it feels like also that there is a disparity in knowledge production, meaning like it is not only about like it's one more time about like it's not about the money, it's about the ideation process. It's about like if you have such a center, you also absorb a lot of good minds. So it's not like that you just like have money and you can do great things. It's like because of this money and also nice people, the good people you have this reputation. So yeah, I think it's also about all the time about these disparities in science and also knowledge production. And you were right that not so many people can keep up the pace that it's there for the countries around the world, and also even like the worldwide collaborations. Like not everybody has the chance to do this kind of collaborations. So
We also have a comment in the chat from the other Alessio that I think cannot have some mic problem. Should I read it for like same name?
Yeah. Read it
Yeah.
out loud. If Alessia agree. Yes.
Okay, so Alessia is saying so she thinks that the last comment, I think about the I don't know which last comment she refers to, but like it can work in general about the discussion. Also relates to the fact that maybe in academia it feels harder to have some real world impact compared to other companies. Yeah, I totally agree with that.
Yeah, it's true. Generally, it's true. Like the steps are way longer, and but COVID was a special case. I think COVID was a special case because government started to listen to researcher and their following models because we were network science and all that stuff was the only one having models on uh, infectious disease propagating over contact networks. So this was a isolated case, I would say.
Mm-mm. And do you think that like maybe it's a kind of a different topic, but maybe just to finish like today's discussion, do you think that what this change of view of research during COVID still is still like impacting, or it's completely erased and COVID is now like a long a thing that happened and is completely closed? I don't know if like my concept was clear.
Yeah, I mean, researchers gained attention, let's say during that period, of course. I think that now, as researchers, we still have some attention, but the problem is that again we're dealing with the elephant in the room. So basically, even if we have attention, let's say, uh, there is something bigger than us, let's say, driving at, let's say, the scientific progress.
Yeah, I mean, there's always that, no? Um, Also, climate change would be an example on government that should listen to to researcher. But of course, there are like opposite forces that maybe make this process slow and painful. So I think nobody has more comments. I think we had a great discussion, to be honest. So thank you very much, Lucio, for being here with us.
Thank you.
And so see everybody at the next seminar. Okay. Bye
See you.
bye.
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 Bye. Thank you. Thank you, Lucio.
Thank you. Bye bye.